I'm not sure. Oh, wait, maybe I got it. Okay, I'm gonna sign this one off. Like, okay, so not the advisor. So I think I got the. Yeah, that's right. I was trying to. It's also about the time. I almost signed this. Hey, I figured I could buy her the pen.
Is it?
It's trying to. Yeah, okay, so it looks good, and then.
Okay.
Let's just see if you switch this PowerPoint.
So you,
Yeah. Oh, yeah. Oh, I guess if you were, try right clicking on raw. And then just like save like hopefully I should do it. Hmm. No, it's still like cut off. There must be some.
should we start over?
Yeah.
It will be actually on mine. It will show as kind of a presenter.
Oh yeah, I
Will
guess.
that be more the same?
Oh yeah. Let's see what we get. I'm not figuring it out.
Okay, it might be showing
Yeah.
presenter.
Well, I could always go in and just like edit the slides on top.
Okay.
If you want to save the pattern.
Yeah, I think it will be.
I think you just can't handle the difference in resolution between your screen and.
Oh, okay. Yeah. Okay. It's already due today. If you can, actually, I check my email again, and then he asked you if you can complete a survey by noon. That would be really helpful for him. Because you want to like, tailor the session to what you need for that. Okay. Today we're going to talk about functions in R. You have been using functions almost every session of this class already. We're going to just have more of a formal, well, still informal introduction to functions. And so the function and loops will be two parts. The first one will be I'll be talking about how you use the predefined functions in R, and also how you can create really simple user-defined functions. And we'll see if we'll have time to go into loops. If not, Nat will be talking about user-defined functions, that you can create your own functions, and also more about loops in the next lecture on Monday. Yeah, again, homework 1 is due by Monday midnight, 4 minutes or 5 minutes before midnight. Okay, functions in R. When I think about functions, it's easier for me to think in terms of the functions in mathematics. Like, so you have a function, say, if you want to call it z, and then you use this function form f, x, and y. Basically, x and y will be the parameters in this function. And then you can define the function as this is the form of x squared plus y squared. And then once you define this function, you can then input this parameter values for the x and the y, and then you can get a value, which is the output value of 25 for that function. So basically in R, the functions I think also take this form as well. So basically you will start with this name of this function, and then you put function, and then you put your argument, so the name of the argument, and then you, in this square bracket, you put the body of your function, which is comprised of expressions, and also output values and all that. And then you close your bracket here. So this will actually define this function for whatever you will call for that function. And if you want to use the function, you need to use this form. Basically, just put the function, the name of the function, and you supply the value for the arguments, just like this one. You put name of the function and 3 and 4. These are the values for your arguments. We're going to see how you do that. I mean, if you already have seen that. The first one is a simple example. So this one is a R-defined R-defined function. So it's the sum. Basically, you will take the sum of all the arguments you put in there. So the function name is sum, and then 7, 2, 2 are the 3 arguments, values for the arguments you have. And another example is, so you create this normal distribution, basically take a random sample of 10 from this normal distribution here. So instead of I just put these values directly in the brackets, here I actually define or have written out the name of the argument. So have n equal to 10, mean equal to 0, and as standard deviation equal to 1. And on the bottom is the output. Basically, there's 10 values from this random normal distribution. So in R, if you want to use a function, you don't know the form of this function, there are several ways to get help. So first, you can use this help and then put the name of the function there. And if you know the name of the function, you can also use this question mark and the name of the function to get to the document for that. Or you can use this double question mark. Or another way you can do is to use help.search and then put basically a string of the things you want to do with this function. That will give you a list of things that can potentially match with what you have here. And then if you want to see an example of this function, how this function is being used, you can use this example function here. So put the example and the name of the function here. Okay, we'll go to the next method first, and then we can switch to RStudio and show you how to do that. And if you are using one function in R, you want to see the whole code, what you can do is just run or submit the name of the function. So say if you want to take a sample, use this sample function in R, you can just submit sample and then you run it. The output or the console will give you this, the bottom part. So basically, so this is the, remember we said this is kind of, you have name and then you have function and have expression. So basically the bottom part is showing you the right hand side of this function. So you can see all this argument parameters, and you can also see the body of this function here. And at the bottom, you can also show this environmental variable or environmental component of this function. Basically, I could show you how these variables are defined. You don't have to pay too much attention to it unless you're creating your own function. So this one will show you the entire code for that function, which is really helpful if you want to, say, just kind of tweak the function a little bit to tailor to your own needs for that one. So instead, seeing the entire code, if you just want to know what kind of parameters I need to assign or what kind of values I need to supply to use this function, what you can do is to use this argument function. So you put the name of the function instead of that inside, and what will give you is basically just the top part. So it's prior to the expression part, just like all the parameters that you need to give value to. So there's several things I want to note here. So you can see this function actually, so we have x, so there are 4 parameters for the sample function. So we have x, size, and replace, and the prop. But replace and the prop actually have an equal sign and have some values there already. So these are the default values for these arguments. If you're not specifying the values for these arguments explicitly, I've taught the SAS class, I kept saying SAS. So the R will use these default values if you don't specify them explicitly. Otherwise, if you want to overwrite the values for this, you can actually say, if you want to use sampling with replacement, you can say replace equal to true to overwrite this default values. And several things when you are calling functions, there are several things you need to pay attention. So just like we mentioned, there's some of the arguments have these default values, and you don't need to specify them unless you want to override them. And also the order of the arguments matter if you are using this positioning matching. What I mean by positioning matching is just like the first one here, if you only supply the values instead of or without writing out the full name of this argument, basically R will do is to match this with the default order of the arguments in that function. So the second function here will be same as our norm 10, 0, 1. because R is matching each of these position to the position in that default order. And also, if you want to use the arguments out of their default order, so it makes sense to specify them. And when you specify these arguments, you don't have to write out the full name, like the replace in that sample function. You can just write out the partial name of that, but it needs to be sufficient enough for R to differentiate that argument from the rest of the argument. Say if you have two things that start with R, you cannot say R equal to something and R equal to something, then R will get confused. We'll see some examples of that to make it more concrete. And the argument values can also be any valid R expression that can return any appropriate value. So basically, you can wrap a function inside of a function. So you can do a lot. Just instead of just using a function and then supply this values or the values for the argument, you can also use a function that has the form that can basically you have function inside of a function which the function inside can return some values for that argument. We'll see that in an example. Okay, so let's switch to our studio. Oh, my computer don't freak out. And, okay. So this might be boring because you have already seen how to use functions in R already. Just several things to make it more concrete. And if you have any questions, please feel free to speak up. So I have several examples. The first, if you want to know if an object in R is a function or not, there are several ways to learn that. You can use this is.function, and then you can put the function name inside to see that. So if I run this, on the bottom, the console tells me that true. So that means basically this is a logical evaluation of that. And if you want to see the code for the predefined function, like the example we've seen for sample, if you do that, on the bottom of this, you can see basically this is the output you have seen from the slides. And then you can use the code being supplied here and then try to change something to match what you need from there. And they have several other functions here that you can also play with. And if you just want to see the arguments, you just use this argument function, and on the bottom will show you this the form of this function with all these arguments specified here. So I know if I need to use this function sample, at least I need to supply what the x is and also the size for this function. Okay, let's see one example of using this sample function here. So we know we need to supply what x is and also size. The first, actually, can someone tell me what I'm doing on 925? Can you see it from the back of the room? Yeah, and actually, what like by how many elements will be in that 100, and they're increasing by 1. Yeah. And then, can I just see from the back? Is that too small? That's fine. Okay. Okay. So, so basically, I'm assigning this to ls, and then I can use this in the second line after that. So what I'm doing here is, because I haven't run that line yet. That's why I'm getting an error. So now this sample function with this list I just created and the size of 20 returns this 20 elements taken from that sequence there. So here you see that we didn't specify any of the arguments in this function call here. But R knows by matching the first element to the first argument in that function call, the default one, and then 20 for the second. And then another way to do that is you can write out the full name of the arguments. So the second one will give the desired results, which will not be exactly the same because it's generated randomly. So if you specify the seed, it will be give you the same. But now you have a different answer, but you have the same type of results from there. And this one, the second one is I normally use to specify a function. So basically, I would write out the full name of the arguments. And with this, you don't have to follow the exact order of the arguments in that function. So the 9 on 28, this will also give the desired results because you have written out the full arguments. So the order of this doesn't matter. So R does how R matches the arguments is first by this perfect matching. So basically, you supply the exact name of the argument, and then it does by this partial matching. So like this 9 on 28. So you only not here, but if you say s equal to 20, so R will be matching that s to size in the argument because there's not another one that has the similar name there. And then the lower level will be by this positioning matching, just like the first one. So know the order of the argument or just specify the full name of the argument when you call a function. So this one, 29, okay, I think I've already said, I was going to ask, do you think that will give you the desired results? But I've already had a comment prior to that, so that doesn't work. So for this one, the 20, so what are, or maybe someone can tell me like how are execute this one, 929. Do you think that will actually work? So what? So is reading that 20 as the which argument in as the x, and then the ls will be the size, right? So by this positioning matching, it will actually just give you returns you this only number there. So it's not the 20 numbers you want to draw from that list. So always pay attention to this if you are not specifying that. Something like 20. Actually, 20 is just the x here. It will actually give you a different. Yeah. Yes. Actually, let's see. Actually, I don't know because it just doesn't make sense. Right. I think you might be also confused because x is just x should be a list, but now x is only. Let's see. Okay, so it can be a positive integer. Yeah, I was wondering if actually might be using, so if you only say 20, it actually gives you from, so a positive integer from 1 to 20, and what it does is to actually draw from that list and then return just a single number, which it doesn't make sense because the size you are actually supplying as 1 to 20, 1 to 100, which is a list of 100 elements here. Yeah. Yeah, so it's not, yeah, I think so. Yeah, I think that's how it does is to basically thinks, okay, so it doesn't make sense. So basically it takes, just like Angela suggested that the ls is take the first element from the sequence you supplied here, so the 1 to 100. Like if we say, if we change this to say 5, and then 20, so we'll give you actually 5 elements, 5 numbers from a sequence which starts from 1 to 20. So if you don't know what it does, you can actually read the document for this random sample. What I did is just I used the question mark and the sample, and you can go and read it. So if you go to the details, you actually shows you when x has a length of 1, what it does on the right hand side. So our help can be helpful sometimes. Okay. So, and remember we talked about the default values for the arguments, like so we have that replace argument, and you can set it to, if you don't use it, the default value is false, so it would not be sampling with, so you will be sampling without replacement. But if you want to actually sampling with replacement, what you can do is to set this replacement equal to true, and by partial matching, you can just supply this R instead of full name of this replace. So this two will give you the similar results, except the numbers will not be exactly the same, but it will give you a similar result. Okay, so there are several ways to use the function. I think I've been talking about the same thing over and over again. Anyone have any questions on this? Or think it's pretty straightforward, right? Okay. And if you want to get more help, there are several ways of doing that. And then, if you want to find out some function within a package, we talked about package like the ggplot we've seen last session. If you want to know something which is inside of a package, but you don't know which package that is, say if you want to use this noS function, if you want to, because some of the packages, if they're not pre-installed, you need to install the package first. But you need to find out which package that is. I mean, you can also Google that, the name of the function, and try to find the package. But another way you can do it is to use this find function here, and then you put the name of that in quotes, and this will actually tell you which package that this function is in. Like also this plot, you can also do the same thing there. Okay. So like the plot, it shows you that this is the package of the graphics. For plot, you don't have to install the package because it's already installed when you first do that. Okay, and if you know something that you want to find out all the objects that you want to you want to know the objects that is relevant or related to something you want to find out, what you can do is to use this function here. I'm not going to pronounce it, but you can use this one. What it does, it will give you a whole list of all the things that may match with this, and you can probably go through this and find the one you would need. So there's several things you can use when you are working with functions. And okay, let's go back to the slides, and I want to show you something, and that when you are using this pre-specified functions, what you may need to pay attention. This actually gives you several things that I think that can be helpful when you are dealing with missing data in R. So if you have a missing data, if you have missing values for some variables, like the female variable we created in last session, that I asked you to actually assign R missing value NA to when sex equals 9, when sex is missing. So for that new variable female will actually have an R missing value there. If you're using a function, say the mean function, what it does, it will actually returns at NA. So it's actually doing this calculation with the NA values being part of it. So it's kind of you're summing up integers and then NAs. What you return will actually give you an NA. If you have that, what you can do is to first you can look up the arguments for that main function and find out all the arguments you can specify for that main function. And then you will find out that you actually have this na.rm, which is the remove na. So you can specify the na.rm equal to true. Basically what it does is to exclude that na values from the calculation and return to a numeric value for the non-missing values. And for missing values, if you want to know how many non-missing values you have for this variable, if you're just using this length function, what it does, it will actually count every observation for that variable. So it will actually include the missing values there. Instead, you can use this. Actually, we talked about multiple ways. From last lecture, we have some other ways to do this. So this one, what I'm showing you is a sum function, but within that, I also have another function, which is the is.na function. So this is what I mentioned earlier. You can nest a function inside of another function. So basically, you are supplying the value of this, the output value of this function to this sum function. What it does, can someone guess? Don't read the second part. Can you just focus on this one? What R is doing here? Then you cannot answer that question. Okay. Don't have the missing, right? Because where you think that it's not. How do you get that if it's not counting? It's counting the not missing, which is the observational negation of, yeah, so this is how RU negation and yeah, so exactly just like you just said. So remember that this dollar sign refers to like which column I'm selecting from the data set, and then is that an A. What this does is to evaluate each observation of that female variable to see if that's an A or not. And it will return a 1, 0, or true or false. And then so that one will actually count, like have a true value for the bird, for the missing value. But if you put this exclamation point there, it will actually returns the opposite of that. So, and then you sum this up, which will return you this number of non-missing values. And can see some examples in that R program. I'll post that later so you don't have to. No, but that was from we made that last session. Okay. So that was a test. Yeah, so it was created last time. And if you don't remember, I also copied the code from last time. Remember, I asked you to create this female variable based on sex, the value of sex, and then you can. Okay, I can just create it right now. So now I just create this female variable which has a missing value, and you can run the several things just like. So if you just use mean without specifying NA remove, it will actually return the NA for that value on the bottom here. But if you put NA the remove there, it will actually returns numeric value, which makes more sense. And then, so if you want to count the number of missing data, what you can do is just take off that exclusion here, and which shows that we actually have 2 missing values. And if you want to count the non-missing values, you just use the opposite of that, which will give you the value. Okay. Okay. So we talked about these are the pre-specified functions. You can use these pre-specified functions, and then you use this to actually make your own functions. So just several things I want to point out. Functions, they are similar to macros in SAS. I don't know if you like that analogy or not. You kind of try to avoid this repetitive coding. Sometimes if you just need to change some of these input values, if you kind of repeat the coding, which will introduce, which is easy to introduce this error when you just copy and pasting. So if you summarize this in a macro or a function, which will be really helpful and avoid potential errors. And then what you can do, I think everyone has experience writing macros. So it's similar to that. Basically, you can find out the common things you want to do over and over again. Just take that part out and wrap it within a function name, and then test it, and then make it reusable. So it's really similar to writing a macro in SAS. And just to go into the form of the function more in detail. So we have the name of the function, and then you put function here. So this needs to be there. And then you put the input argument. It can be X or Y. You can name this using other name. It doesn't have to be X and Y, but you need to make sure we'll define them here. You need to use them later here. So it's kind of corresponding to what you will be using on the bottom. So this will be the input arguments or the macro variables you are creating. So the variables you need to, or the parameters you need to supply for that. So for this, so we have name and arguments, and you have this body of this function. And here, this is just a really simple one, just like the earlier the function I've shown you, x squared plus y squared. So the sum of squares. You have this body of the function, and what you want to do is also ask R to return or to output some value. So here, have this 9 will code this thing return square. So if you are writing your own function, would you'll be following the form of this function. And then if you want to use or call this function you just made, you just call it like how you do it with pre-existing functions. So it's not different from that, except you need to run this part first before you you call it first, and then the multiple ways to call function here. So this is just one simple example, and then here's another example, and I think Nat will show you more creating your own functions. more complex functions if you want to make. So this one compared to the first one is a little more complex, but I'm still using only two parameters here, so it's still x and y, and there are some intermediate parameters I'm creating inside of the function, and then what I'm outputting is this TST. So we'll be outputting that. Yes. Actually use it differently. So there's actually, I should have one example in our studio. To me, I normally just use, I don't actually put return there. I just write it. Because basically, if you just write a name or variable, it will actually print out to you. But there maybe something was returned. Now do you know?
Yeah, I think by default it will return. If you don't have a return, it will return the last thing that you have printed without an assignment.
Yeah. But I think if you have a list of
Yeah.
things you have, actually a list of objects you are outputting, you probably need to use return.
Yeah, and it can help if you have some sort of if-then clauses, because then it'll basically, if you can force it to come back, say like, oh, okay, I'm done here. Like if you, I think the sample, if you look at the sample function,
See.
they, oh, maybe they don't. I was looking at either sample or sample in. But,
yes, sample doesn't have return.
Yeah, so they don't use it there, but I usually use it because it helps me remember what I'm doing. But.
Yeah, I think if for me, if I'm using, I've been using really simple functions. So if I use that, just kind of return a final value of something. I don't have to write a return, which it's kind of, you are still using a return explicitly. Yeah. I think there's something equivalent in SAS to that, although you didn't write it out, it's actually have that. Yeah, output is one. Like in the data stack, you're using output. You can specify output, but if you don't specify, it's still running that. So it's similar to this.
Oh, another reason why return is helpful is because if you don't have a value of return, it'll send you a null, and so you can use that to test if your function works. So like, for example, if you write a function, I have to make an example, but basically if you don't use return, you might get like missing or something that comes out, and you don't know if it's because there was like missing in your data or if the function didn't work. If you use return explicitly, it'll return null, like if it couldn't do something. So return can help you track down the error, I think, if you have a complicated function.
Yeah, maybe we can create some example for next week. Yeah. And we can also include talk about conditioning, conditional execution with if, then, and all that. Okay. So I think I can save the for loops for the next lecture. But if you have any questions regarding what we have talked today or the homework, we have a few minutes that we can talk about that. Or everyone is done with their homework? Is that too easy? Or things don't make sense that you want to talk about? Yes. There's no silly question. then you can randomly pick 5.
Yeah, sample the 5 snacks.
Yeah. No, we're right. Um, let's see. So I think it depends. So if you're working on like a continuous variable, we'll probably prefer to see median and then IQR and also mean and max. It doesn't matter for other variables here. So you can give us all 6. And if you have missings, you can also supply the missings. Like the mate. Actually, I don't remember if mate was part of the. That's another question. But yeah, so we just give us the things you think that be helpful when you are examining the data set. We're not really strict about, okay, you didn't give me the mean here or the median here. But just, we're more interested in, which function or how, the way to find out something about the variable. So, something else. One part on the project, I think I have mentioned in the first lecture that we want you to basically to reduce the amount of the work towards the end. So we can start at the very beginning, just kind of walk through the semester. Then you will have something physically done by the time it's due. You don't have to rush to finish everything at the end. So for this one, we just ask you to think about your project data set and also the project idea. But just like to have it similar to a project, like a real project you would be doing. I mean, it can be a real project for your purpose. It just think that if you want to use this for a poster presentation or just a short spotlight presentation, think about what do you have for a background, like several lines for a background and object for a project. And then after that, you can think about the methods and all that. So yeah, it's basically divided into these parts that you can start thinking about it. Try to make the life so this one should be submitted on Sakai under assignment. I think there's already assignment 1 has already been created, or homework 1 has already been created. So the project will also be part of that, the homework document. So you can just put your answers to the same document and then submit that to us. And if not, that's all, because I used 10 extra minutes from last session to give it back to you. Okay, otherwise we'll have a good weekend. We'll see you back here next Monday.
I have a question.
Yes.
So like, from the scripting class, so we were asked to do like tables. So like when you do the table, you get it comes like this. How do you get it to look like nicer with like tables or like because it's kind of hard to like I don't know.
Yeah,
like
it's a hard to
a nice output.
exactly.
So
Yeah.
is there a way to
We'll talk about ways.
okay. Is it kind of complicated? I was wondering if there's you definitely know how to do and they're really
We have this, actually there are multiple ways to make it, but it's kind of required. We actually do we have a kind of output.
Yeah, don't be that.
And I just find it after.
Right.
Like Mark.
Yeah.
They're packages that have kind of either one around or we do like doing the website.
Yeah.
Little one every day. I'll show several options. Yes. I don't really like that either. Very hard.
Okay. Well, I guess we'll get there.
Oh, it's one it's actually oh yeah, I think it's still especially
Yeah. No. And then we go back there and be like, no, I think it's quality. And I was like, no, like something I can do to like just half staff something that makes you said 11:55. I know.
Using the same with that. Yeah, and right. I'll ask him. And you can use any place. Okay.
I talked to Anna Kucharski. She is cardiac rehab question that she wants to know. So I was thinking about she wants to know what hospitalizations, for people who are hospitalized, what are the predictors of people who get that
Oh,
referral?
okay.
Whether regionally or something that happened clinically.
Cool. And then you can also do some kind of mapping or stuff, which will be.
Yeah, I mean, it's only 4 sites. Eric's only 4 sites. But yeah,
You could do, yeah. I think it's, yeah, we're some, I'm thinking just like thinking of ways that later we will let guys to do some cool stuff with the, yeah. I mean, it doesn't have to be GIS. There are like several things we're showing later. So I think that would be helpful if you have. I think the DSS. Yeah. And, yeah, I think you can also use that class if you.
oh yeah.
Yeah.
I hope so. Well, I
Yeah.
have to look at it because I don't think it is.
Right. Yeah, I'll ask him about projects, which that might be one. Yeah.
Okay.
Okay.
Thank you.
Well, okay.